Hello everyone, welcome to the channel. In this tutorial, we are going to deploy a simple Spring Boot Hello World application to a Kubernetes cluster. Before we begin, just a quick note. This is not a tutorial on Java, Spring Boot, or Kubernetes in depth. I will assume that you already have basic knowledge of Spring Boot and a general understanding of Kubernetes concepts such as clusters, pods, and services. The main goal of this video is to demonstrate the complete workflow of taking a Spring Boot application, containerizing it using Docker, pushing the image to Docker Hub, and then deploying that image to a Kubernetes cluster. In this video, we will deploy the application to Kubernetes in two different ways. 1. Using kubectl commands. 2. Using Kubernetes YAML manifests. This is the first session in a series where we will explore more topics related to Kubernetes and its integration with Java applications. As the series progresses, we will go deeper into different Kubernetes concepts and practical use cases. If you are interested in learning more about these topics, consider subscribing to the channel so you get updates when new videos are released. Now let's start by creating a simple Spring Boot Hello World application. Spring Boot Application Overview. If you look at the project, this is our Java-KB8-integration Spring Boot application. This is a very simple application that contains a single REST controller called Hello World Controller. The purpose of this controller is just to demonstrate a basic API response. When we run the application and access the API through the browser, it should return a simple message: "Hello World." Let me run the application and verify the output. To verify the output, we can open the browser and hit the API endpoint. As you can see, the application returns the message, "Hello World," which confirms that our application is working correctly. So now our application is running successfully on our local machine. The next step is to containerize this application using Docker. Now that our image is working locally, the next step is to push it to Docker Hub so that it can be accessed by other systems, including our Kubernetes cluster. Before pushing the image, we need to tag it with our Docker Hub repository name. So let's tag it first using the docker tag command. The docker tag command follows this structure: docker tag, source image :tag, destination image :tag. The destination image consists of the Docker Hub account name, followed by the repository name and the tag. Since we have not specified a tag here, Docker automatically assigns the latest tag. After tagging the image, we can push it to Docker Hub using the docker push command. Let's push it to Docker Hub. If you haven't logged into Docker Hub yet, you can do that using the docker login command. Once the push is complete, we can go to Docker Hub and verify that the image is available in our remote repository. We can also view this from the Docker desktop application. In the next step, we will interact with our Kubernetes cluster and deploy this Docker image to run our application as a pod. Now let's create a Kubernetes cluster. In this tutorial, I'm using Azure Cloud, but you can use any cloud provider as long as it offers a managed Kubernetes service. First, we enter the basic details required to create the cluster. For this demo, we will keep everything minimal and select bare minimum resources just to run our application. Next, we configure the node pool. This is where we define how many nodes we want and what size of virtual machines will be used. Here, you also have an option to enable node auto-provisioning or auto-scaling if required. For now, I will keep it simple and proceed with the default configuration. Once everything is configured, click on Review plus Create. Azure will validate all the configurations. If everything looks good, click on Create to start provisioning the cluster. Now you can see that the deployment is in progress. This step might take a few minutes, so let's wait until the cluster is fully created. And there you go. Our Kubernetes cluster is now ready. In order to interact with Kubernetes cluster, we need two main things: a deployment and a service. The deployment is responsible for running our application pods, and the service is responsible for exposing those pods so we can access them. For now, I have copied the deployment and service file here. We will go through them one by one. Let's go through deployment first. We define the API version, apps/v1, kind, deployment. We give it a name, Java-Kb8-integration. Then we define replicas, in our case, just one. Next, we define the selector and labels so Kubernetes knows which pods belong to this deployment. Inside the template, we define our container. We specify the image, Teralliance/Java-K8s-integration::latest. We also set image pull policy to always, so Kubernetes always pulls the latest image. Then we expose port 8080, because that's where our application runs. We also define minimal resource requests, just enough to run our application. Next, we add health checks. Readiness probe, to check if the app is ready to receive traffic. Liveness probe, to ensure the app is alive. For now, we can make both pointing to the root path, /. Now our deployment file is ready. Next, let's go through the service. Again, API version v1, kind, service. We give it the same name, Java-Kb8-integration. We choose type, LoadBalancer. This means Kubernetes will expose our app externally. Then we map port 8080 to the container port 8080, and we connect it to our pods using labels. Now, both files are ready. Let's deploy them to Kubernetes. Before deploying then to cluster, we first need to connect to cluster. Let's go to cluster and click Connect. It will open a sidebar where they have mentioned commands to connect to cluster. Let's fire them one by one. Once you have configured your credentials to connect to cluster, we may proceed to deploy application. Go to the project root folder if you are not yet, and run kubectl apply-f deployment.yaml. And then kubectl apply-fservice.yaml. Now Kubernetes will start creating the pod. Let's check the status. Wait until the status becomes active. Now let's check the service. If you are using a cloud provider, you will get an external IP. Now open the URL in your browser, and you should see your application running. And that's it. We have successfully deployed a Java application on Kubernetes. You can practice it by creating your own cluster. But not to forget deleting all the resources once you are done with it. Thanks for watching.